Okay, good morning, or depending on when you're watching this, good afternoon or good evening. Um, I'm back for day 8. Okay, now just to review, the biggest thing that we are going to use is the power rule in lots of different ways. So the power rule says the derivative of anything x to the nth power is n times x to the n minus 1 power. Okay, where we left off in the last video was finding derivatives of polynomials. Now, a polynomial is simply a collection of terms to some power, right? Like I could have x to the fourth plus x to the second plus 2x to the first, right? So really, we're just using the sum and difference rules that say to find the derivative of a sum, right, or of a polynomial, f of x plus g of x, it's simply f prime of x plus g prime of x. And the same thing with their differences. Okay, so let's go ahead and solve some problems and apply some things today. All right, find the derivative of each of the following. Now, looking at A, B, C, and D, the thing that I'll say is, if we're going to use the power rule, we should first set ourselves up to make sure that it's easy to apply the power rule. Okay. Later on, we'll show you other ways you could possibly look at these problems. But for right now, we're going to rewrite this, right? Okay. Using powers, right? In other words, another way of saying this is that it's x squared minus 4, right? And that 5 over x can even be written as 5 to the 5 times x to the negative first, right? So just knowing that we can rewrite is going to be a lot easier for us. All right, so what is the derivative then? Well, we just apply the power rule to x squared. The derivative of x squared is 2x, right? The derivative of negative 4 is 0, right? And the derivative of 5x to the negative first is negative 5, right? Because I multiply negative 1 times 5 to get negative 5. And then it's x to the negative second. And rewriting that again, I would end up with 2x, get rid of that 0, minus 5 over x squared. All right, so that's our final answer. Okay, the first thing we're going to want to do with this one is FOIL everything, right? So I'm not taking the derivative yet. I'm simply rewriting x squared times x to get x cubed. I'd get negative 3x squared. I'd get x minus 3, right? It's much easier now to say, let's take the derivative of x cubed. You write the 3 out front, 3, x to the second. So we applied the power rule. The derivative of negative 3x to the second. Remember, the derivative of a quadratic is always 1 degree lower. And that would be 2 times negative 3, which is negative 6, x to the first, right? The derivative of x, or the slope of x, is 1, right? And then the derivative of negative 3 is simply 0, so I'm not even going to write it. So g prime of x is 3x squared minus 6x plus 1. Okay, when I have this one, basically, I would probably say that it's x minus 3 times x minus 3 times x minus 3, right? And just rewriting, I know anytime I multiply x minus 3 times itself, I get this, x squared minus 6x plus 9. So then I would have to FOIL everything, right? I would have to multiply x times this, negative 3 times this, right? That would give me x cubed minus 3x squared, right? I'm kind of doing those two together. Then negative 6x squared and 18x, then 9x and negative 27. So now, cleaning that up first, I have x cubed, I have negative 9, let's see here, negative 9x squared, and I have 27x minus 27, right? So now, so all I did was just apply some algebra. Now the power rule becomes easy. The derivative of x cubed is 3x to the second, right? The derivative of negative 9x squared is negative 18x. The derivative of 27x is 27. And the derivative of negative 27 is 0, so I'm not going to do anything there. Okay? All right. Looking at D. This one, I would probably rewrite first as similar to A, where I had x on the bottom. Now I have x to the 1/2 on the bottom. So I get 2x squared over x to the 1/2 minus 3x over x to the 1/2. And writing those, right, what would that give me? It would give me 2x to the 3/2, because the subtraction of exponents says 2 minus 1/2, or 4/2 minus 1/2 is 3/2. And then 2/2 minus 1/2 for this one is 1/2. So I'm just rewriting those as positive exponents. Now I can take the derivative. All right, let's take a second to show you and make sure. You have the 2, you multiply the 3/2 out front. Then you get x to the, remember what the power rule says? You take 3/2 and knock it down by 1. Well, 3/2 minus 1 is 3/2 minus 2/2, which is 1/2, right? And we'll clean that up in a second. Then I have my 3, I put the 1/2 out front, x to the. Well, if I knock 1/2 down 1, 1/2 minus 1, or 1/2 minus 2/2 is negative 1/2, according to the power rule. So now I took the derivative, and here it's just about cleaning it up. 2 times 3/2 is 3, x to the 1/2. Right? Negative 3 times 1/2 is negative 3/2. But what I'm going to do with that exponent is write it like this. So it's really 3x to the 1/2 minus 3 over 2x to the 1/2. And that would be your derivative. Okay, let's take a few minutes to apply what we've learned. And we're actually going to go back, way back to tangent lines, to write some equations of tangent lines using the power rule. So write the equation of a tangent line at the given point. Remember, the equation of a tangent line can be thought of as y minus y1 equals m times x minus x1. Now it's important to note, x1 and y1 come from the original function. And right here, I have x1 and y1 at 1, negative 1. The slope comes from taking the derivative at a point. So let's first ask the question, for f of x, what's f prime of x? That would be the derivative of x, which is 1, and then the derivative of negative 2x squared, which is negative 4x. Now, that's the general derivative. To find the derivative at a point, I need to plug in the x value that I'm looking at, which is 1. So what's the f prime of 1? That'll be 1 minus 4 times 1. 1 minus 4 is negative 3. Now I have everything I need to plug in to the point slope formula, right? According to the point slope formula, my point is 1, negative 1. My slope at 1, negative 1 is negative 3. So my answer becomes y minus negative 1, okay, equals negative 3 times x minus 1, or y plus 1, negative 3, quantity x minus 1. If you wanted to, you could write that in slope-intercept form, but point slope form is very common on the AP exam, and we can leave it like that. Right? If you want to read that caution, I kind of spoke about it, but let's move on to part B. Write the equation of the tangent line at the given value of x. Now, a couple of things real quick. I have my function. I have a point called x equals 1. One thing that we're going to want to do is figure out the y value as well. Above, they just told me the x and y value. Well, if x is 1, y equals, or f of x equals 2 times the square root of 1, which is 2. In other words, the point I'm going to use in the point slope formula above is I'm going to use x value of 1, y value of 2. So what I need to do here is find the derivative, okay? Now, Before I do that, maybe it's best to rewrite the original function as 2x to the 1/2 power, right? Because a radical can be written as an exponent just like that. So what's the derivative of 2x to the 1/2 power? Well, it's 2 times 1/2 times x, and in case you're still unsure, to the 1/2 minus 1. That's the whole power rule, right? The power rule says you write the exponent out front and you knock the exponent down by 1. So cleaning that up, 2 times 1/2 is nothing. So I would get x to the 1/2 minus 1, or x to the negative 1/2, right? F prime of x is x to the negative 1/2. Or f prime of x is 1 over x to the 1/2. We usually like to write those with positive values. Another way of thinking of x to the 1/2, well, let's come back to that. Because what I need to do is find the slope at a specific point. The specific point is this x value of 1. F prime of 1 then is 1 over 1 to the 1/2. Now you're probably thinking to yourself, what does that mean? What's 1 over 1 to the 1/2? Another way of doing that would be 1 over the square root of 1, just for the purposes of evaluating, right? Anything to the 1/2 power is just a radical. Well, 1 over square root of 1 is just 1. Now I know the point is 1, 2. The slope at that point is 1. So I simply go to that point slope, y minus 2, because my y1 value is 2, equals the slope 1 times x minus 1. And that's good. All right. All right, very good. Just a couple other things, a couple applications, and then we'll call it a day. Now, finding locations of horizontal tangent lines, right? Let's think about what a horizontal tangent line is. And we've come across it a little bit. Remember with, let's just look at just a very general sketch of an upside down parabola. Remember that we said sometimes the slope of a polynomial, sometimes it's positive, sometimes it's negative. And if that happens, then if the slopes are positive and negative, then in between the slopes have to equal 0. So a horizontal tangent, right? A horizontal tangent is basically a spot where f prime of c will equal 0 somewhere, and this should be more of a horizontal line perfectly, so forgive my sketch, but anywhere that's a perfectly horizontal line, there's no slope, that's a horizontal tangent. So what we're going to do here is just kind of work on, we have a function, let's check the derivative, okay, and then we'll answer the question. What's the derivative of x squared plus 4x minus 1, right? Or another way I could say it is like y prime, right? F prime of x, y prime, they're the same thing. It would be the derivative of x squared, which is 2x. The derivative of 4x is 4. And the derivative of negative 1 is 0. Now, to see where it has a horizontal tangent line, we're just going to, for the horizontal tangent, right? We're just going to set the derivative equal to 0. In other words, 0 equals 2x plus 4, okay? Then 2x equals negative 4, right? Or x equals negative 2. That's the spot where there's a horizontal tangent line, okay? Now, at what point means I already know the x value, but we're going to have to go back and find the corresponding y value, right? Because I want a point. And I go back to the original function for that point. So it happens when x is negative 2. When x is negative 2, y would equal negative 2 squared, 4 times negative 2 minus 1. And with that being said, I get 4 minus 8, negative 4 minus 1 is negative 5. So let's write that as a point. The point where the horizontal tangent occurs is at negative 2, negative 5. And maybe take a second and plug that into your calculator. What you should notice is if you plug that into your calculator, since it's a parabola, the vertex is probably the location that we're looking at, right? Okay, last part of the day, ensuring tangency to a given line. So I have a cubic function and I have a line. Find the value of k so that the line is tangent to the function. Okay, there's a process here. The first thing I would say is looking at the line, I know that the slope of the line is 6, right? And that's the slope of the tangent line. Now, I also can think about slope in terms of the derivative of that function. And according to the derivative of f of x, the derivative of x cubed is 3x squared. The derivative of kx, which sounds weird, is simply just k, right? Since the derivative of x is 1, it's really k times 1 or k, okay? What I really need to do is ensure that these two things are equal to each other. So let's set 3x squared plus k equal to 6. And what I can also do right now is then rewrite k as negative 3x squared plus 6. Right now, it's looking for the value of k so that the line's tangent to the function. I have an actual expression for k. K is simply negative 3x squared plus 6. So let's go ahead, maybe I'll just make this a second part, and plug that k value into the original function to see what happens. I would end up getting y equals x cubed plus negative 3x squared plus 6, right? Replacing k with its expression times x, right? And distributing that, I would get x cubed minus 3x squared. Let's see here. No, that would be negative 3x to the third plus 6x, or negative 2x to the third plus 6x, right? Now, this is the fun part. Once I get here, you guys just keep going. And I know that there's something called y equals 6x minus 2. So I can actually then set, I'll call this like part 2b. I can set 6x minus 2 equal to negative 2x cubed plus 6x, right? I'm just kind of going with all the expressions that I have. The nice thing about this one, when I do that, is I end up getting negative 2x cubed equal to negative 2, or x cubed equals 1. Okay? X cubed equals 1 means that x has to equal 1, right? X has to equal 1. Well, now that I know all of that, this is where I'm going to go back to the beginning and say, I said k was equal to negative 3x squared plus 6. Therefore, k is equal to negative 3 times x, which is 1, squared plus 6. K equals negative 3 plus 6 gives me my answer, and my final answer is k equals 3. Okay? Great job. Let's follow up on that real soon, and have a great evening.